today, might as well go right into it. Okay. So if you look at Canvas, I guess I got off of it already. There is a where did I put it? Canvas 418. There is a test review. Okay. I've already got the test written, and so this is information that I derived after looking at the test, not like things I'm like, I'm going to test on this. Right? So the test is going to have, when I say will have, the test has some short answers based on material presented in class and discussed in the lecture in the lab. So we've covered 6 weeks so far, and the test will be inclusive of all of those 6 weeks. So if you go back to the first week, we spent some time talking about different types of models. We categorized models in different ways. And so you should go back and look at those slides. We also talked about what a raster is. And I didn't really put this on the test, but you definitely need to understand that it's a regularly spaced series of points, a series of values that represents a real-world value. We're modeling a real-world value, whether it's elevation, temperature, precipitation, and those numbers represent that. So it's a type of model. Simplification of reality. That should be pretty ingrained in your head by now. But then you should also understand this concept of what a raster band is. Although we didn't use them a whole lot, we introduced this concept. I talked about it when I brought up the Laguna Beach data set for the first time. So a raster band is basically a way to store multiple rasters next to each other in the same file format. And when we have a multi-band raster, we can display them together, usually as an image composite. All right, you should understand resolution. Resolution, specifically, we're talking about spatial resolution here. If you took a remote sensing class, you might have talked about other types of sensor resolutions, but I'm talking about spatial resolution. So when I say that a cell is 10 meters by 10 meters, then I'm saying that that value that's in that cell represents that 10 by 10 meter area. All right, how are coordinates stored in a raster? They're not explicitly stored in every single cell. Okay? Only the corner of the raster is known, and the positions of everything else are relative to that corner location. So the cell size is used to determine the coordinate for every point in the cell, in the raster. So we talked about capability suitability modeling. So go back and look at the slides in terms of constraints and factors. So there will be a question like that has to do with how do I implement this type of capability suitability modeling? With like if I'm gonna weight the factors and then add them together, how would I actually do that? Well, weight implies that you multiply each by a weight and then add them together. All right, so you should understand this concept of map algebra, that we can get answers to our questions by figuring out, we did this even today, figuring out the mathematical operation that gives us the proper values in the cells that we want to answer. So if we're trying to find runoff for every cell, we need to find out what operations yield runoff. And in our case, it was some multiplication, some division. Okay? But even in that kind of more obscure question I asked earlier about swapping out the the sinks and saying, I only want this sink to be preserved. You have to think about how you'd actually do that and come up with a formula for doing that using math and logic. So those are the two things you have to work with, math and logic. So map algebra is the process of basically doing numerical computations with raster data sets because they're numbers. All right, so you should understand basic map algebra operations. There will be on the test small rasters, kind of like what you did today in the lab, but usually even a little bit smaller, maybe only 8 cells. And I'll ask you to do a particular operation. Okay? They'll be pretty basic, so like you might have to add 2 rasters together. So you just need to know that you add the same cell over. And you should know that that's a local operation. So you should look at the slides. I put a little bit more here than, I'm not going to ask you to do anything we didn't do in class. Okay? Anything that we didn't implement in a lab, don't worry about it, because that won't be on the test. But anything that we didn't implement and to discuss in the class. So the test is also going to have a number of questions where you'll see a grid. Oh, this is what I meant. Usually 3 by 3, some of them are 4 by 4, and then a function from which you'll have to fill in an empty grid. So these include even a focal operation. So if I ask you to calculate the focal mean for a particular cell, you need to know that you need to find the neighborhood and add all those up and divide by the total. That's how you calculate mean. You should really understand what a conditional operation is and how it works. So you should be able to read a conditional operation and say, okay, if this condition happens, then the result is going to be this. If this condition doesn't happen, the result's going to be something else. And so if I present a conditional operation and then ask you to fill in what the values will be, you should be able to do that. So like, as a practice, here's Excel. So if I had a bunch of values like this, and I said, con input, and this is the input. It'll look a little different than this on the test. It'll be a little more clear. Input greater than 1. 5. If it's not, then it gets a value of 0. All right, so what would the outputs be? Okay, what would the output here? It wouldn't be 5. If I put it in this formula, or even if I stated this as a word, the value is greater than 5. Sorry, if the value is greater than 1, it's going to be 5. So what would the output here be? 5. What would the output in this cell be right here? It's a 1. Yeah, 0, exactly. Okay, you guys got it. All right, you should know and be able to identify when it's appropriate or what type a particular operation is. Is it local, focal, or zonal? It seems like there's still some confusion here, like what a focal operation is and what a zonal operation is. Particularly, when would I use a zonal operation? Okay, so you need to go back and look at what a zonal operation is and when you do it. Basically, it's when you're trying to find out or to summarize everything that's in a particular category. Typically, they're regions. So you're saying, what's the average elevation in a particular region? That's a zonal operation. All right. So here, it's more important that you understand what the output values represent than being able to you're not going to have to calculate slope, aspect, hillshade, or visibility, but just what the numbers mean and what those data sets produce. All right. You should understand distance, both cost distance and Euclidean distance. So what do the cells represent in a cost distance raster? And then also look right here. You are going to have to create at least one diagram. It's either going to be the workflow from cost distance or it's going to be the workflow for water modeling. So you need to understand both of those workflows because one of the tests will require you to tell me each step in the process to get from point A to point B. So you need to go review those steps. Okay, so that's why I said you need to have the water modeling concepts in the workflow and the distance workflow. I don't think this will take anywhere near the full class period to accomplish. I've given similar tests in the past, and most people finish. Almost everybody finishes in less than 2 hours. There are plenty of people that finish within an hour. Okay. So, yeah, if you're having trouble studying, remember you can look at the slides, but also you can go look at some of the helps for those operations. All right. So there's not like there might actually be a couple just like what you would call multiple choice, like, but it's not a full multiple choice test. That's not what it is. All right. Any questions about that? All right. So so you guys will take that. Looks like Ashley's already left, but she'll be the TA next week. I mean, she'll be the test proctor next week.
Did you just record it, Dr. Ray?
Yeah, I recorded everything.
All right.
Everything is recorded, including what I just said.
Okay, appreciate it.
No problem, and I'll upload it. I'll probably upload it right now before I even leave, because the internet at my house isn't as fast as the internet here. I mean, it's decent. I can watch Netflix, but it's not as fast as particularly for uploading.
I got 1 gig fiber. It's just as fast as
Yeah, we don't have 1 gig fiber out in the sticks.
This is a significant portion of what I don't want to have to do.
Yeah, I have a Purvis address, so it tells you how far out I am. But it's still way closer to come here than it is to go to Purvis. But well, no, it's closer to go to Purvis, but it's I'm only like 4 miles south of the junior high, just barely across Richburg Road, which I think is the boundary. All right, y'all are free to go if you don't have any questions. One thing I do want